Howdy. I have been watching him since some time, since I found his channel. Unfortunately, I don't have always the time to really dive into it and stay with him, but we are in a way on the same wavelength, I think. I recommend you to check him out. Let's give him a quick word, and then I want to show you an article which just popped in my news feed.
There's nothing left, but it still had the exact same effect. And he said this is just impossible. The experiment was done over and over and over again. The experiments on using osmotic uptake of South Pole and North Pole exposure on seed experiments. I tell everybody, and I made a recent video on the water quality where I used the super huge monster magnet. You don't have to use a monster magnet to create structured water. People say, how does it vary? Actually, the effect that it has on you is different, but there's empirical, and I will make videos of this. I've done it before. The osmotic uptake of the water by seeds is a whole lot faster. It works a lot quicker for uptake into the living systems and tissues. It just is. It changes the qualitative nature of the water. I don't care if anybody believes this or not. People didn't believe me when I told them about magnetic exposure seed experiments. Yet already, since I've been making those videos for years, there have been many thousands and thousands of people that have duplicated that experiment. The Rawls, Davis, magnetic South Pole, North Pole seed exposure experiment, and everybody's confirmed. It's like, wow, I didn't think it would work, but you seem so adamant. You show examples of seeds, which I've done many, many videos. You could Google search it or YouTube search it. You could see that it does work. Do the experiment yourself. The best.
Sorry for interrupting here, but I wanted to show you now this article. I will put a link below to his video and check out the others. He has very, very nice magnetic experiments. So let's check out the article. I haven't read this. Space Ref, whatever this is. Earth. How magnetism could explain Earth's formation. By Keith Cowing. Cowing? November 2nd, 2022. So that's 2 days old. I turned 45 years old yesterday. So I'm very old. And if you take the number 4 and 5 and add it together, you get the number 9, which is also very interesting. I was thinking about yesterday making a video, but I didn't. Anyway, there are several theories about the Earth and the Moon were formed, most involving a giant impact. They vary from a model where the impacting object strikes the newly formed Earth a glancing blow and then escapes through one where the collision is so energetic that both the impactor and the Earth are vaporized. Now, scientists at the University of Leeds and the University of Chicago have analyzed the dynamics of fluids and electrically conducting fluids, hence magnetohydrodynamics, and concluded that the Earth must have been magnetized either before the impact or as a result of it. Immanuel Velikovsky, I recall, the claim that this could help to narrow down the theories of the Earth-Moon formation and inform future research into what really happened. Yes. Professor David Hughes, an applied mathematician in the School of Mathematics at the University of Leeds, said, "Our new idea, first of all, it's not new. Second of all, it's not theirs." This has been proposed many decades ago. It is not new. It is not theirs idea. It's not new and it's not theirs. Now I said it 3 times, probably you remember, hopefully. But anyway, our new idea is to point out that our theoretical understanding of Earth's magnetic field today can actually tell us something about the very formation of the Earth-Moon system. At first glance, it seems somewhat surprising and previous theories had not recognized this potentially important connection. Despite we have interplanetary magnetic fields, we have Aurora Borealis, where you can see the Birkeland current, which is providing Earth with energy and everything else, keeps us alive. You can really see it if you can see Aurora Borealis. You don't need any tool for that. Hannes Alphen, Christian Birkeland, and such. This new assessment is based on the resilience of Earth's magnetic field, which is maintained by a rotating electrically conducting fluid in the outer core, known as geodynamo. Professor Fausto Cattaneo, an astrophysicist at the University of Chicago, said a peculiar property of the Earth's dynamo is that it can maintain a strong magnetic field but not amplify a weak one. The scientists therefore concluded that if the Earth's field were to get switched off or even reduced to a very small level, it would not have the capability to kick in again. It is this remarkable feature that allows us to make deductions about the history of the Earth's early Earth, including possibly how the moon was formed, added Professor Cattaneo. Professor Hughes added, and if that's true, then you have to think, where did the Earth's magnetic field come from in the first place? Our hypothesis is that it got to this peculiar state way back at the beginning, either pre-impact or as an immediate result of the impact. Either way, or none of those two, any realistic model of the formation of the Earth-Moon system must include magnetic field evolution. You don't get a magnetic field without having an electrical current and vice versa. Well, that was so short. Okay. So let's start with this first. Thunderbolts Project, Wolf Thornhill, Donald Scott, and all the others. Charged planets. Gravitationally induced dipoles tend to separate charged planet acts like an electret. Free electrons tend to drift toward the surface. Like a particle accelerator, the electrical stress modifies the apparent mass of the planet. Removing electrons from the surface through lightning etc. reduces the mass of the planet. This is my own a self-made picture. Here at the center we might have a plasmoid. And that's a laboratory plasmoid. And you can see in some places I try to use another color, which is probably better visible. Let's take blue. It goes out here and makes connections, let's say at random places. They aren't random, but they seem to be random. Here we have something which isn't connected, but that's lab plasma. It's moving all the time. If you scale it up, the deepest quake ever measured, as far as I know, was 987 kilometers, which is approximately as deep as here. It's really hard because I don't know. I cannot measure. I could have counted, but it's no point. Anyway. First layer of our magnetosphere is about 3,000 kilometers above the surface. Exosphere, the highest part of our atmosphere, in a way, which still belongs to Earth, which is not space, or how to put it, is 500 kilometers high. Taking the deepest quake, one of the measures of Earth's diameter, put this one in half, take this one off, you end up with still 5,877.5 kilometers, which is left to the center. So there is still space in order for something being there. And if we would take even though the exosphere off that, we would still have more than 5,000 kilometers. Which would mean we would have more than 10,000 kilometers here for something being there. And I think Earth is a live geoid. Geoid? Geoid. Many of you have seen this. Probably some of you have one at home. And beside that, on the right side, we are back to Wolf-Thonin's repellent core, what I just showed with the first picture. And I do not claim I know either that I know everything or that I would understand completely everything. No, I'm just trying to wrap my head around that. In order to do so, I try to get as much information as possible. Not all iron is magnetic. By Anne-Marie Helmstine, PhD. Here's an element factoid for you. Not all iron is magnetic. The alpha allotrope is magnetic, yet when the temperature increases so that the alpha form changes into the B form, or beta, the magnetism disappears even though the lattice doesn't charge. Key takeaways. Not all iron is magnetic. Most people think of iron as a magnetic material. Iron is ferromagnetic, attracted to magnets, but only within a certain temperature range and other specific conditions. Iron is magnetic in its alpha form. The A form, alpha form, occurs below a special temperature called the Curie point, which is 770 degrees. Iron is paramagnetic above this temperature and only weakly attracted to a magnetic field. Magnetic materials consist of atoms with partially filled electron shells, so most magnetic materials are metals. Other magnetic elements include nickel and cobalt. Non-magnetic diamagnetic metals include copper, gold, and silver. While iron is magnetic sometimes, ferromagnetism is the mechanism by which materials are attracted to magnets and form permanent magnets. The word actually means iron magnetism because that is the most familiar example of the phenomena that the one scientist first studied. Ferromagnetism is a quantum mechanical property of a material. Sorry for that. It depends on its microstructure and crystalline state, which can be affected by temperature and composition. Yes, it's about the charge and many other things. And I know people who know much more about this than me, so let me share you still one little piece of things I gathered in order to get it. Or trying. I'm trying. Let's see. So this is Edo Kaal's structured atom model and transmutation of elements. Let's give him a listen, and I still want to show you then quickly Gerard Pollack, which talks about water, but now let's check out this first.
So to recap SAM, when we look at the SAM, structured atom model, the following needs to be kept in mind. We have a duality, which we call a proton-electron pair, with the electrostatic force acting between them. This force is the causal mechanism for the principle of densest packing that creates geometrical shapes based on the platonic solids. These geometrical shapes in a specific order, sequence and number, create all the elements. So the neutron is not regarded as a fundamental particle, but a combination of the proton and the electron, because a neutron does, a free neutron, I should say, does decay into those two. So a duality, each other's opposites, it would seem. One is heavy, one is light, one is positive, one is negative, etc., etc. So when we look at the new neutron in a schematic drawing over here, we can see right there in the center what we call the inner electron. The dotted line around it is like the neutralized zone where the inner electron makes a connection to both protons on either side. So this represents deuterium, heavy hydrogen if you will, heavy water. And we are left with a positive half charge on the left side and a positive half charge on the right side. But the whole nucleus, of course, is +1. And then we have the outer electron, in this case, -1, and making the whole charge 0, all based on the duality. In the model, as we have on the website, this is the way we depict it. And that's about it. Then, when we go a step further, We can see here the groupings, or nuclets, as we call them. James one day told me, we need a name for this. So he came up with it. We did some Googling, he did some he found some synonyms, etc. And the term nuclet was born, so that's how we're going to call it. So this is this deuterium, the first one, the most important one. Here we see helium, two of those, if you will. This is lithium, the third element that we know. And the blue one here is carbon. Those four are the repeating main structures, if you will. And they keep repeating, as you will see a little bit later on, into the elements as they become heavier.
So, I really recommend you to check this out. And let me show you still Pollack. So now we just dive in somewhere into Gerard Pollack's talk about electrically structured water, part 1, 2013. Now I leave someone else talk because I cannot talk today, obviously.
We know that these exclusion zones exist, and the question is what's really going on. So the questions that I want to answer are, first, is this exclusion zone, this phenomenon general, or does it just apply to some polymers and a couple of gels? Does it really arise from the ordering of water? Because if it did, it would mean a huge number of molecules ordered, and this is against conventional thinking. And since creating order requires energy, where does the energy come from to create this if it really is ordering? And finally, what I want to spend most of the time on is, can the ordered zone help explain everyday phenomena? And by phenomena, I mean, for example, why do clouds exist as they do, and how come when you sprain your ankle, it swells very quickly?
Yes, I recommend you to watch this also. But anyway, I gotta do stuff, and it's maybe better than just sitting here and talking. Thanks.